right, we're going to look at a few more examples of solving systems of equations by elimination. If you notice my problem, I've got my x's lined up, my y's are lined up, my equal signs are lined up, and my constants are lined up. So I'm going to look at my x's and my y's and see if anything will eliminate. And I don't have anything that has the same coefficient there. So what I'm going to do is I'm going to have to multiply both my first equation and my second equation in order to get my x's or y's to eliminate. It doesn't matter whether you focus on x's or y's. I'm going to probably focus on x just because my numbers won't be quite as large. So when I look at a negative 7x and a negative 4x, I need to make one of those a positive 28x and one of those a negative 28x. I know that because the least common multiple of 7 and 4 is 28. So that's the number that I'm shooting for. So I'm going to multiply everything in this top equation here by a negative 4. And that will make that a positive 28. So let's see here. Let's go ahead and multiply everything there. So negative 4 times negative 7x is a positive 28x. Negative 4 times negative 8 is going to give me a positive 32y. And then negative 4 times positive 9 is going to give me a negative 36. All right, so let's go to the second equation here. I'm going to change colors. So I want this one to end up with a negative 28, so I'm going to multiply everything by a positive 7. So when I do that, I end up with negative 28x. 7 times 9 is going to give me a 63y. And then negative 22 times 7, well, I don't know that one off the top of my head, so let's multiply that. That's 14, 15, so it's negative 154. Okay, and I'm going to erase this down here so that I can see what I'm doing. So now I can see where my x values will eliminate. So I'm going to change colors here real quick, and we're going to add these two together. So when I do that, I have 28x and minus 28x. They cancel out. If I add my y's, let's see, I have 95y equals, if I take a negative 36 and a negative 154, that gives me a negative 190. So I divide both sides by 95. And that means y equals a negative 2. All right, awesome. Now I've got to take this negative 2 here, and I have to substitute it into one of my equations. It can be one of the original equations, or it can be one of the new equations. So I'm going to go back to the original equations, and I think I'm going to choose, I'll choose the top one. So I have a negative 7x minus 8y equals 9. That was my original equation. So I'm going to take this negative 2, and I'm going to substitute it in where y is. So negative 7x minus 8 times negative 2 equals 9. So I have a negative 7x. Negative 8 times negative 2 is a positive 16 equals 9. So now I'm going to subtract 16 from both sides. Negative 7x equals negative 7. I divide by negative 7, and I see that x equals positive 1. Perfect. So are we going to write this as an ordered pair? So my ordered pair is going to be 1, negative 2. All right, let's take a look at another example where we have to multiply both equations. So I'm going to scroll down here, and I'm going to change my color again to green because I like to color code this. I think it's easier to follow. So again, my x's are lined up, my y's are lined up, my equal signs are lined up, and my constants are lined up. So now I want to look and see if I can find a way to make either the x's or the y's eliminate. So I'm going to work with x again because I think I can easily make this a positive 10x and a negative 10x, and I can cause those x values to eliminate. So I'm going to start with the first equation. I'm going to multiply everything here by 5, and that will give me my positive 10x. So over here to the right, let's see, 5 times 2x is 10x. Then 5 times 8y is 40y, so plus 40y, equals 5 times 6, which is 30. Awesome. So then I'm going to go down here to my second equation, and I'm going to multiply everything there by 2 because I want to make this a negative 10x. I'm trying to get the x's to eliminate. So 2 times negative 5 is negative 10x. 2 times negative 20 is negative 40, so I have negative 40y. And then 2 times negative 15 is negative 30. Now, what I notice here is that everything is going to eliminate. I end up with nothing here. Let me change that color again real quick. I end up with nothing for x. My y's eliminate, and my constants eliminate. So what I'm left with is 0 equals 0. So my question is, wait a minute, is that true? Does 0 equal 0? If you end up with this in a situation where everything eliminates and you're left with a statement that's true, like 0 equals 0 or 5 equals 5 or 3 equals 3, then we would say that we have infinitely many solutions. Meaning that there is any x and y value that we plug in will work. It's as if these two lines were graphed, were sitting on top of each other. So every x and y value for one is going to work for the other. So we would say infinitely many solutions.